The ozone layer, a region of the Earth's stratosphere containing a high concentration of ozone, O, molecules, plays a crucial role in protecting the planet from the harmful effects of ultraviolet, UV, radiation from the sun. UV radiation is a type of electromagnetic radiation emitted by the sun, and while some UV radiation is essential for life on Earth, excessive exposure can have detrimental effects on living organisms. The ozone layer acts as a natural shield, absorbing and filtering out a significant portion of the sun's harmful UV radiation. Here's an overview of the role of the ozone layer in protecting Earth from UV radiation. 1. Absorption of ultraviolet radiation. Ozone absorption. The ozone layer primarily absorbs the majority of the sun's high-energy UV radiation, particularly in the UVB, medium wavelength, and UVC, short wavelength, regions. This absorption occurs through specific interactions between ozone molecules and incoming UV radiation. Formation of ozone. Ozone is continually formed and broken down in the stratosphere through a dynamic process. Oxygen molecules, O, are broken apart by solar radiation, and the resulting oxygen atoms, O, combine with other oxygen molecules to form ozone, O. 2. UVB and UVC absorption. UVB absorption. The ozone layer is particularly effective in absorbing UVB radiation, which can cause damage to living tissues and is associated with skin cancers, cataracts, and other health issues in humans. UVC absorption. UVC radiation, with even shorter wavelengths, is extremely hazardous, but fortunately, almost all of it is absorbed by the ozone layer and does not reach the Earth's surface. 3. Protection of living organisms. Protection of human skin. The ozone layer provides a vital shield against harmful UV radiation, reducing the risk of skin damage and skin cancers in humans. UV radiation can cause DNA damage and mutations, and the ozone layer helps minimize such effects. Eye protection. Ozone absorption also protects the eyes from the harmful effects of UV radiation, reducing the risk of cataracts and other eye disorders. Protection of ecosystems. UV radiation can have detrimental effects on various organisms, including plants and marine life. The ozone layer helps preserve the health of ecosystems by limiting the impact of excessive UV radiation on these organisms. 4. Climate regulation. Temperature control. The ozone layer plays a role in regulating the temperature of the stratosphere. Changes in the ozone layer can have implications for atmospheric circulation patterns and climate. 5. Impact on materials. Material degradation. UV radiation can lead to the degradation of materials such as plastics, rubber, and certain types of fabrics. The ozone layer provides some level of protection against this degradation. 6. Human activities and ozone depletion. Ozone-depleting substances. Human activities, particularly the release of ozone-depleting substances, ODs, like chlorofluorocarbons, CFCs, and halons, have led to the thinning of the ozone layer. ODs break down ozone molecules, reducing the ozone concentration in the stratosphere. Montreal Protocol. The international community responded to the issue of ozone depletion with the Montreal Protocol, an agreement aimed at phasing out the production and consumption of ODs. The protocol has been successful in reducing the emissions of these harmful substances. Conclusion. The ozone layer's role in protecting Earth from harmful UV radiation is critical for the well-being of living organisms and ecosystems. While the international efforts to address ozone depletion have shown positive results, continued vigilance and adherence to protocols are necessary to ensure the recovery and maintenance of the ozone layer. Protecting the ozone layer is not only essential for human health but also for the health and sustainability of the entire biosphere.